Okay, welcome to Algebra 2, Unit 3, Lesson something. It's covered by my face. It is Lesson 2, Part 1, and we are going to park ourselves in Lesson 2 for quite a while. Lesson 2 covers some really critical concepts and skills for Algebra 2 moving forward, and for those of you that are going to move on to pre-calculus, this is a must-have skill, and so we're going to sit here for a while in it to try to look at this particular skill from a variety of different angles. So what we ultimately want to do in this lesson is solve quadratic equations, and we like to be able to solve them by graphing. So we want to look at the connection to, say, the Desmos graph or the graph of the parabola, and we also want to be able to solve them algebraically. And that tends to be the piece that is harder to wrap our heads around. And then, of course, to apply them to real life problems, we want to know what the points on the parabola are and the algebraic methods that go into finding those points and what they mean with respect to actual real life things. Okay, so that is what we're looking for. So some key vocab and ideas. Some of this is a review from the last lesson, but we want to focus on what we are doing, not just how to do it. And that can be really tempting for a lot of students, is just show me how to do this. Show me how to get the answer and I'll be fine. The problem with that is that if you don't know what you're doing, then once you stop doing it, you will forget the how. Okay, so the key to retaining how do I do this is to understand what you are doing. And so we want to go over this vocabulary. What are factors? When you see the word factor in the directions to a problem, you need to know what it is you're looking for. So factor as a verb, I mentioned this in the last lesson, factor being used as a verb means find the factors. Well, factors are things that are multiplied. Okay, and they could be, I mean, we're using intentionally like a super vague word there, like things that are multiplied. But I'm using it because things could be, say, numbers, but they could also be variables. And in the last lesson, we looked at multiplying binomials. So we looked at, say, multiplying x plus 2 times x plus 3, where the two things being multiplied are these expressions that have an x and numbers in them. So for example, we're just going to factor the number 12. Somebody might say, factor the number 12. Well, there's a couple different ways you can think about this. So one of the ways you could factor a 12 is you could break it up into like factor pairs. So you could say 12 factors into 1 times 12, okay, which is true, 1 times 12. Or it factors into 2 times 6, or it factors into 3 times 4. And all of those would be correct factorizations of the number 12. And we would talk about this by saying 1, 2, 3, 4, 6, and 12 are all factors of 12. Okay, so any number that turns up in that list. Now, being able to generate these like pairs of numbers is something you want to get pretty good at. And I do have a sheet that's going to have the numbers 1 to 100 with all of the factor pairs. It can feel a little bit overwhelming, but when you see them, you realize that like there's a couple numbers out there that are really ugly, like they have lots and lots of factor pairs, but most numbers don't. Most numbers only have a couple of pairs for you to choose from. Now, there's another way that sometimes we'll look at factoring, say, the number 12. And that could be by like creating like what's called a factor tree. And so I might say to the class, what are some factors of 12? And half of you are going to say 2 times 6, and the other half say 3 times 4. Okay, so let's just kind of take a look at, like, half of you say 2 times 6, and the other half of you say 3 times 4. Okay, just both of them are correct. Well, if you look at those numbers, you'll see that some of them can be factored further. Okay, so this 6 could be factored into 2 times 3. And then what we would do is we would bring that 2 down. And this expression right here is what's called the prime factorization, 2 times 2 times 3. So you say, well, what about the other people in the class who said 3 times 4? Well, take a look at this. The 4 factors into 2 times 2. And if you look at that final factorization, the order of the numbers is different because of just the way that we wrote it. We could have said 4 times 3, mean, that would have been the same. But the prime factorization is the same. Both of these factor into 2 2s and 1 3. So what you want to do depends on the problem. One thing that teachers sometimes like about prime factorization is everybody should land at the same place. So the prime factorization, it cannot be factored any further, and everybody should get there even if the path that you take to get there is a little bit different. Sometimes you're just interested in all the pairs of numbers that I guess can be multiplied to give you that number. Okay. So what are we doing when we factor? Basically, you're looking to determine the actual factor numbers. Okay. So you are, what are we doing when we factor? That would be the verb. Okay. Essentially, you are looking for the factors, meaning the noun. Okay. So you're looking nouns. Nouns. Okay. You're looking for the factors. So I could say factor the number 12, and you would be looking for the factors 2 times 2 times 3. All right. So that is really, really important that we are like super clear on that vocabulary. The result of the multiplication is called the product. Okay. And we covered that in the last lesson as well. Again, I know the language can be a little bit boring, but it is absolutely critical that when I say something in class that you are hearing the same thing that I'm saying. All right, so we do need to do a review of GCF factoring. This doesn't come out in a lot of like the early problems that we're going to look at, but it is going to come out, and I want to make sure that we cover this territory beforehand. So GCF, you're probably more familiar with the acronym than you are with the concept. GCF stands for greatest common factor. And as you know, I know I'm harping on the vocabulary here, but if you don't know what factors are, then when you see the acronym GCF or greatest common factor, then you don't know what that is either. And that vocabulary lack starts to snowball. So essentially the GCF is the largest factor that 2 or more terms have in common. So most of my examples here have 2 terms because that is mostly what we deal with when we're doing the factoring, but I did throw one in here that has 3 terms. Remember, terms are things that are added or subtracted. So just so you can see, okay? So the way we would look at this, okay, we've got x squared is one of the terms, and then 2x is the other term. Now, ideally, you do not want to write anything down for this, okay? You're going to look at it, you're going to look at x squared, you're going to look at 2x, and you're going to say they have an x in common. But for now, I'm going to write it out. So x squared literally means x times x. And then 2x means 2 times x. And when I write it that way, it makes it apparent that there is an x in common. And remember, that's what we're looking for. We're looking for what they have in common. And then we will say it this way. We're going to factor it out. Essentially, we are going to undistribute. So we're going to take that x that is circled, and we're going to pull it outside the distribution. And what will be left inside? X and a minus 2. Okay, that's how that works. Now you might be saying, well, what happened to the other x? Okay, I get that question a lot. There were 3 x's, and it's not a bad question, okay? So there were 3 x's in this line here, and now there are only 2. Well, this x got undistributed. So watch what happens if I were to distribute it. I would do x times x, which would give me the x squared, and then x times negative 2, which would give me the negative 2x. Okay, so we just reverse distributed. Next example is a little bit more challenging. Okay, we have 3x squared. So I'm going to write that as 3 times x. And then we have these 6 and 6 factors into 2 times 3, and then we have the x there. And so this one's just got more stuff in it. So 3x squared is 3 times x, and 6x, the 6 factors into 2 times 3, so you have 2 times 3 times x. Now remember, we're looking for the largest factor, okay, the greatest common factor. So there is a common factor of 3, okay, so that would be a factor that these two terms have in common, but it's not the greatest common factor because there's actually more that they have in common. They also have an x in common. So what that means is that my greatest common factor is actually 3x. And what's left is x plus 2. And again, you might be saying, but wait a minute, like now there's a 3 that's gone. Like what happened to the other 3? We factored it out. Watch what happens when I distribute. 3x times x would give me the 3x squared. 3x times 2 would give me the 6. Okay, so if you just distribute it back, you will see, oh, no, the 3x did not go anywhere. For the last one, we'll do the same thing. This is 3 terms. So I have 2x squared, so that's 2 times x. And then just had a cat go crazy. The 4 factors into 2 times 2. And so you have 2 times x. I don't know if you can hear him or not. I promise he's fine. And then we have the 6, which factors into 2 times 3. Now, remember, it's the greatest factor that 2 or more terms have in common. So if you've got 3 terms, all 3 terms have to have the common factor, which in this case is a 2. Okay. Now you could say, all right, Miss Taylor, but these guys have an x in common. Yes, they do, but this one does not. Therefore, it is not in common to all of them. So you're looking for what is in common to all of them. When I factor out that 2, I am left with x times x, which is x squared. And here I have 2 times x, which is 2x, and then a minus 3. So this is what we mean when we say factor out the GCF. Okay, that's what we mean. So if you're doing this from home, I want you to pause the video and I want you to work on practice 1, practice 2, and practice 3 to see how well you can do this. Okay, if you make a mistake, it's not a big deal. You're going to unpause the video and we're going to go over it, but I want you to try it first. Okay, you need to be the one to try it first. Right? Now, I mentioned earlier that this step right here, where we're doing that prime factorization, I don't actually want you guys to do that, okay? Now, if you need to do it, if you need to see it in order to see what it is you're going to factor out, then by all means do it, okay? It is a great way to see more of the legwork of the work, but like you don't have to do that. So what most of us would do for this first one is I would look at the 4 and the 2, and I would say they have a 2 in common. And I'd look at the x squared. Okay, so if you can't see what I'm looking at, the 4 and the 2, and I would say they have a 2 in common. And I'd look at the x squared and the x, and I'd say, all right, they have an x in common. And then I would almost like reverse my thinking here. 2 times what would give me the 4? That would be a 2. X times what would give me x squared? You could also think of that as if I have 2 x's and I factor one of them out, what am I left with? I am left with 1. Now, this could be tricky right here, okay? 2x, and then notice that there's a 2x there, okay? So we're actually taking all of that out. If you tell me 0, okay, think about distributing 2x times what would give me 2x. If you put a 0 here, 2x times 0 would not give me 2x. We actually need a 1 there. Now, if that was a little bit confusing to you, okay, I'm going to do this out on the side, and I am going to erase it because I need to have some space here. you might have done it out like this. 4 is 2 times 2, and then you have the x times x plus 2 times x, and you probably just left it like that, okay? What I want you to consider is this. Could you say 2 times x times 1? I'm pausing to give you a chance to think about it. Okay, 2 times x times 1. Well, yeah, you could. You might not have thought to do that, but you could say 2 times x times 1. When you do that, then you can see, okay, they have a 2 in common, they have an x in common, so the common factor is 2x, and then you would be left with that 2x. And then over here, you are not left with the 0. You are left with a 1, and you should notice those are the same. All right, and that would be the reasoning in that. So sometimes that does trip students up. If you need to pause the video to write that down, do that, because I am going to erase that work because I need the space for the next one. All right, so let's get that cleaned up. All right, next one, I would look at this and I'd say, all right, x squared and 7x, what do they have in common? They have an x in common. And if I have 2 x's and I took 1 out, what would be left here? Or you could think x times what would give me the x squared. Both of those are totally fine ways to think your way through that. If you have a 7x and you took out the 7, you took out the x, you'd be left with the 7. Or you could say x times what would give me 7x. And that would be the 7. Now, this one, probably more of you are going to want to do that prime factorization out, okay? Just because you're looking at it like, there's a little bit more going on there. So we have 2 times 2 times x plus, and then the 6 factors into 2 times 3. And I can see that they have a 2 in common and they have an x in common. So my GCF is 2x. And I am left with a 2x right there. And I am left with a 3. All right. So there we go. Okay, so hopefully that went pretty well. If it did not, okay, if that was really confusing, you guys know when I say after school, send me an email, screenshot your work, do what you need to do. I'm more than happy to go over this again. I actually have some pretty cool illustrations I can use to go over this with you if they would help, but I need you to ask, let me know if this is something that we need to do, okay? All right, so let's bring it back to the area model. All right, so can we figure out the factors? That would be the base and the height, or length and width, if you prefer to use those words, if we know the product, that is the area. Now, there's actually a couple ways you can reason this out. And the first ones are fairly simple because they'll look like this. So you can start up here and say, okay, if I know that the area of this rectangle is x squared, okay? I know the area of that rectangle is x squared, then what has to be the base and the height? What times what gives me x squared? And hopefully you did enough of the previous problems to know that that would be x times x. And that's really the only way you can do that is x times x. Now that once you have that, you actually can do the rest of it with multiplication, which is what makes the area model so good, okay? Because that is the only time you actually need to factor in the area model. The rest of them, if you need to, you can do by multiplication. So you could do this by factoring. You could say, I have a 3x here, and then I have x, what would have to go up here? Or you can reverse the reasoning and say x times what would give me the 3x? Well, that would be 3. And now you've got one more left, and you actually have 2 boxes left. So you can pick and choose here. You can use either the negative 6x or you can use the negative 18. Whichever one you don't use, you can use as a check. So I usually go over here. Okay, I like to use the variables better. The number part can get a little bit big, not always, but again. X times what? Okay, so the width of the box is X. What height would give me an area of negative 6X? Well, that would be negative 6. And here's what I mean by checking. Once you have it all filled in, we haven't dealt with a negative 18, use that as a check. Negative 6 times positive 3 should give you negative 18. And the factors would be x minus 6 times x plus 3. There's my base and my height. Okay, base times height. Now, sometimes people will be like, well, what if you wrote x plus 3 and then x minus 6? Multiplication is commutative. Think back to the last lesson when we had that 3 times 5, 3 by 5 rectangle. Didn't matter if it looked like this or if it looked like this. Okay, it was the same area either way. So you could write x minus 6 times x plus 3, or you could say x plus 3 times x minus 6. Either one is fine. Now, this next one is a little bit trickier. Because, and then this is why I wanted to go over that GCF. Okay, so essentially you need to do one GCF factoring somewhere. Okay, typically we will, and there's no good way for me to go back and do it. Hang on, I'm gonna pause this video and figure something out. Okay, I think we're back. I just copied the problem over here because I can't, like in class, I can just go back a slide, but when I'm recording, I can't. It messes up the timeline of the recording, and I have a cat trying to get on my lap. I love you, baby boy, but no. So typically when we are factoring, we'll either do the GCF this way. So we'll look at 4x squared plus 6x, and we'll put the GCF right there. Or we'll do these two and write the GCF up here. You can do it some other ways, okay? But typically these are the ways that would do it. I avoid negative numbers. Now we have only positive numbers here, so we don't have to worry about that. But if, like, say the 6 was negative, I'd avoid that and I'd go with the positive numbers. Okay. Otherwise, I usually go with the smaller numbers. So I'm inclined to go with the 4x squared and the 2x. And what I'm going to do is look for the greatest common factor, and I'm going to write the greatest common factor on the outside. So looking at 4 and 2, I know that they have a common factor of 2. And looking at the x squared and the x, I know that they have a common factor of x. And my blues don't match, so that is the kind of thing that bothers me. Okay, there we go. Now, really, that's all we need to do for the common factoring. So the rest of it we can just figure out using multiplication, which is another great reason, like, to use this model. Looking at this position right here, 2x times what would give me 4x squared? Well, 2 times what would give me the 4? That would be 2 times 2. And x times what would give me the x squared? That's an x. We might say, oh, Miss Taylor, that was obvious. I could have done that. Not necessarily. It could also have been 4x times x. Okay, it could have been that. It wasn't, but you cannot just assume it's going to be 2x times 2x. Looking at this position right here, 2x times what would give me 2x? That would be a 1. And then you can go either here or here. For me, this one looks easy. So 1 times what would give me 3? That would be 3. And now I will use this one as a check. 2x times 3 does give me 6x. And so my answers are 2x plus 1. That's one of my factors. And the other factor is 2x plus 3. So I apologize for clicking through if I leave Oh, gosh, it's like if I leave the laser pointer activated and then I tap on the wrong part of the screen, it advances the screen. So I just got to be really careful about what I've activated, and then I can't go back. But we did get it in. So if you've got your notes outline and you're watching this video to make up like from the notes, you should be good to go. Okay. I am going to erase that example though. So if you need to copy it down, pause the video and get that copy down, and then we'll go ahead and erase it. Right. So in factoring, we're going to need to fill in the boxes. And that's where this can be challenging because you're not just going to be given the product. You're just going to be a little bit of legwork to do. We start with filling in the blanks. So this is a very scaffolded lesson. If you think of what scaffolding is, it kind of builds up. So as we go through the problems, more and more of that comes to you. We, of course, will go over them. We'll talk about how to do it. We'll look at some strategies for doing it and all of that. But if you've done enough of these, what you know, because you've done enough of them, is that the x squared is always going in that upper left box. In fact, when we get to more advanced multiplication and what's called polynomial division, the highest exponent, what's called the degree, always goes in that upper left-hand box. Now, here's where it gets challenging. This is my area. It's supposed to add up to a -2, but I have a -8. So to fill this up, I need to think, what plus the -8x is going to give me that -2x. Now you can do that out algebraically. So I could like add the 8x to both sides and it'll tell me that my question mark has to be a 6x. Most students don't do that. Most students just like look at it and think, okay, this is too negative. It's like -8, so it's more negative than it needs to be. So whatever this is needs to be positive, and then they use their factor families. I might do this. I wanted to get a bunch of number lines for you guys to help with this step, but you can do this. Okay. So here's 0, 1, 2, 3, 4, 5, 6, 7, 8. So you're down here at the -8. This is where you are. And this is where you want to be. Okay. So you were given this -8, but where you want to be is the -2. So you would go 1, 2, 3, 4, 5, 6. And you went in the positive direction. So it would be +6, and you can get it that way. This is actually what I picture in my head. Okay. I picture a number line and I picture like moving on that number line. So you're at the -8 because it was provided for you, but you wanted the -2, which means you had to go 6 in the positive direction. We get the 6x. Once you have that, we can break this up. So what have to be the dimensions on that upper left-hand box? X times X. It's the only way to get X squared. There's no other way to do that. I have had students ask me, well, what about 1 times X squared? Yes, that does multiply to X squared. It will never, ever, ever happen on these problems. You will always want to split the X's up. And the reason why is because when you look here and here, the X's are split up. If you did 1 times X squared, you'd have an X squared in one of those positions, and we don't. Okay, so it's not a bad suggestion, and it's an excellent observation, but it won't happen. All right, so X times what would give me the 6X? That would be the 6. And then pick your poison over here. You can look at the -8x or the -48. I like the -8x there. X times -8 is going to give me the -8x. And then do my check here. +6 times -8 does give me -48. So my factors are X plus 6 and X minus 8. All right. I think there is, actually don't know what's coming up. Well, I mean, I can see there's another example, but okay. So another fill in the blank one. And if you have done enough of these, you know that the constant is always in the lower right-hand box. So that x squared is always in the upper left. The constant is always in the lower right. Now, the tricky part is getting these two, because you might be given one and you need to fill in the other one. Or in a regular factoring problem, you won't be given either of them. And so that's, and we'll talk about that. Like, we're not doing that today. But I have a 14, or I need a 14, and I have a 12. So what plus the 12 would give me the 14? That would be 2. Now remember, it's not like 2, it's 2x. It's just when we're talking about it, we usually only talk about the numbers. That one's easier because they're all positive. So the one that we just did had the negatives in it, and that can make it messier. Draw a number line out. If they're positive, usually it's a little bit simpler. Or if they're both negative. Okay, that can go well. Now, this is one of the ones where you do need to do a GCF, okay, because there's more than one way to split this up. It could be 3x here and x here, or it could be 3x here and x here, and it would matter. And the reason it matters is because you got to align them with the 12 and the 2. You could switch those around, okay, but we were given it that way. So I like this direction because the numbers are smaller. Okay, I kind of am not thrilled with that 2 there, or 12. So 2 and 3 do not have any common factors. Those are both prime numbers. So I like that. X squared and x, what do they have in common? They have an x, which means the 3x must be right there. Okay, if you switch them, you will find that something doesn't work. And there's a video coming up, unless I choose to re-record it this year, but where I messed something like that up in the video. And when I go to check it, when I'm doing like the little check, like that I was telling you about, like use that last box as a check, it didn't check. And I actually left the mistake in and went back and fixed it so that you guys could see how the check is supposed to work and what you should do if something doesn't check. Okay, moving on. I like this. Again, I'm kind of avoiding the 12. It's just a little bit bigger than I want. So I'm going to look for this position. X times what gives me 2x? Well, 2. And once again, I'm going to avoid that 12. I just don't want to deal with it. 2 times what gives me 8? And now I'll use the 4, or use the 12 as the check. 3x times 4, 3 times 4, there's my 12. Okay, and I get the 12x. So the factors for this are 3x plus 2 and x plus 4. And that is your final answer. So you do need to actually write the final answer to the problem. You cannot just leave it on the area model. There's more ways to do this. There are several different methods for doing factoring. We actually, as a math department, algebra 2 department, we kind of came across this one for a later skill called polynomial division. And this model makes polynomial division really, really, really simple. And when we realized how well it worked for polynomial division, we went back and started doing it for factoring as well. It turned out it worked better than some of the other stuff that we were doing. Okay, so where does that leave us? So the classwork and homework are in your Desmos accounts. So you should have set up your Desmos account as part of the teacher communication assignment. So you should have that. It should be like with your email and your password. Let me know if there are issues. For your classwork, you are going to log in and do 1A. And for your homework, you are to do 2A. If you can knock them both out in 10 minutes, awesome. But that is the breakdown on that. And then as you work, I want you to think about these questions. What patterns do you notice about what goes in the upper left box? What patterns do you notice about what goes in the lower right box? And what do you think will be the most challenging parts of filling in the boxes? Just kind of being aware of what you're doing. So thank you for your patience and with me like kind of messing up one of those slides. Hope I recovered okay. And you guys always know where to find me if you have questions about the lesson.